Welcome everyone to my LeetCode Biweekly 130 contest. Contest 130. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be starting contests live. We will be answering questions in the chat. We'll be giving hints in the chat. So make sure you come by and join us every weekend. Code along with us. No code will be shared during the contest, but immediately afterwards, we'll go through solutions for all 4 questions. So make sure you stick around. As usual, if you enjoy LeetCode contents, do check out the rest of my channel, like and subscribe to stay up to date on new videos. Let me just do a quick sound check to make sure that Alrighty. So hello, I see some people in the chat already. Welcome. I hope you're having a wonderful morning or evening, depending on where you are in the world. We will be starting a contest in about 10 minutes. Hopefully you can all do well this time. And we'll see how it goes. In the meantime, I'm going to attempt the daily problem as a sort of warm up. Today's weekly problem is actually really hard. Well, it's not. Sorry, let me take that back. It's a hard daily problem, but it's not that difficult. It's not that difficult. I think I got it sorted. I think I got it figured out. Hi, AD3301. Good evening. It's funny because in my part of the world, as you can see from my window, it's actually bright and sunny outside. So it's in the morning. But I know for many of you guys, it's it's nighttime. Just after dinner, I would expect. Alright. So has anyone else tackled the daily problem for today? Daily problem. Minimum cost to hire K workers, given N workers. Yeah, this question is quite interesting. So you have a quality here, which is how much each worker is sort of worth and how much their wages are. And because in this LeetCode problem, unlike in real life, you get paid based on how productive and how good of a worker you are. You basically have. So let's say this person is worth 3 and their minimum salary is 4. It means that if you hire him, everybody has to be paid at least 1.3 times. 1.3 times. Let's see. You're given 2 integer arrays, quality, wage, and quality, and you want to hire exactly K workers to form a paid group. To hire a group of K workers, you must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum wage expectation. So AD3301, you're doing live streaming tomorrow, but good luck. I will be just watching the video. Oh, no problem. So I do the bi-weekly contest when it's on, and when it's not on, I do the weekly contest. Because the weekly contest for me, it's on Saturday night, and I don't want to spend all my Saturday nights in front of the computer. I just want to go out and have some fun. So when I can, I'll do the bi-weekly contest, which is in the morning for me. And if there's no bi-weekly contest that weekend, I'll do the weekly contest. So Jatin, I'm going to do my first contest of my life. And between the last 2 weeks, I stopped DSA. So any tips for me? Well, when I did the first contest of my life, I got my ass kicked, man. It was a very humbling experience. I thought I was a very good programmer. I've been programming for years and years, but the questions are pretty hard. The first few questions are not difficult. So if you want the tips, my tip is focus on getting the first 2 questions right. So if you can do the first question, you can do all the first questions. You're that means you're learning. You can do all the question B's, all the second questions. You're an okay programmer. Question C's, the third questions, are kind of more challenging, and then the last questions tend to be really hard. So normally I finish 3 questions. I usually don't finish all 4. And that's true for a lot of people in the chat. People finish between 2 to 3 questions in the chat. So if your first contest, likewise as Zio Gaming, welcome. If your first contest, don't set your expectations too high. Just aim to learn something, and just aim to be a little bit better than you were the last time you did it. At least that was my experience. But that said, many of these, how will it go? Give me an update. For sure, yeah. Just hang out in the chat. Let us know. Down to earth. How to earn 2,000 plus contest rating. So Rupesh Ravate. The contest rating is based on your rank. So basically, every question is worth a certain number of points. And you get 2 scores. 1 is the number of points you get, and 2 is the time you submitted your last passing question. So you answered 3 questions, then your time will be the time you submitted question 3, assuming you do them in order. So what they do is they rank everybody first based on your score, how many questions you answered, and then after that they do a tie break based on who answered questions quicker. And so your rank is basically based on your sort of rating is based on your rank. Yeah. You have 1,500 rating. Oh, very nice, very nice. Yeah. To be honest, I feel like, because for some of I actually teach programming. So I've always thought, if your goal is to become a good competitive programmer, that's fine. You should focus on contests and rating. If your goal is to become a better programmer, better software engineer, then this rating is just one of them. It's just contests and puzzle questions are just one aspect of being a good software engineer. So don't worry if your rating is high or low. I don't know what my rating is. I don't really check. But I feel like the most important thing is to just have fun and learn a little something. It's a sub-skill skills, exactly. Show my profile. I don't know how to show my profile. Oh, my ranking is not that good either. Yeah, so this is mostly based on your what you might call it. Based on your contest rank. Yeah, I don't know how these things work. Oh, 1,800 plus is almost 2,000. Oh, I love that. Thank you, Rupesh. I like that mindset. That is exactly the right mindset. Yo, 600k plus. Hi, S. Vashif. Hey, I remember you from last week. Not doing contest today. No worries. If you don't want to do the contest, it's fine. Just hang out. Why don't I do a thing? So let me show the contest question on screen, so that if you're just watching the video, you'll be able to see the question and you can sort of do them yourself. What is my highest rank? I don't know what's my highest rank. It's not very high because I don't know. I've never come close to the sort of contest winners at all. I just like doing this, honestly. Okay, hang on. The contest is going to start. So, for the people who are not... Oh, I need to register. So the people who are not doing the contest, I will show the problem on screen. and then I'll talk about it. You can watch the problem on screen. Yeah, thank you so much for the subscription. It helps a lot. Yeah. So those of you who are not doing the contest, you can just see the problem on screen. I don't show my code, unfortunately, because it is supposed to be a contest. You're not supposed to share answers. But I will go through all the answers when the contest is over. Yeah, but I will try to put the questions on screen, so even the people who are not doing the contest live get to follow along. Yeah, I'll think about the best way to do it. Yeah, appreciate everybody's. Hey, Swastik, welcome back. I remember you. You show up quite a bit. Keep explaining. No need to show code. Yeah. So this is not my fault. I can't explain this. Okay, awesome. Yeah, so I actually do my contest on a different browser tab. Which is why you don't see me coding, even though I'm actively doing something. You're given a 2D matrix grid of n by n. And I'll try to look at the chat from as often as I can to make sure I can interact with folks. Of course, I'm also doing my own problems, so this doesn't always pan out. Equal to a cell below it if it exists, different from a cell to a right if it exists. Okay. Hey, Rohan Sharma, welcome back. Welcome back. It's always good to see familiar faces. It's good to see familiar faces. Yeah, first one is not too difficult, I hope, for people. As usual, if you need help, just type in the chat. I'll try to get to you. If not, sometimes other people will help you too. That's the nice thing about, doing programming as a group rather than by yourself. It's more fun that way. String S represent the coordinates of I. S represent the tag of, wow, what's this? A valid square. String S, where points I represent the coordinates of I, and SI represent the tag. Sorry, I have to turn on the switch to a light mode because I can't see the picture in question 2. A point is inside the square if it lies inside the boundaries. So second question, yeah, sure. Okay, let me get to a chat. So in question 1, do you use 2 loops? In question 1, let me see. In question 1, yeah, you use nested for loop, exactly. Do a nested for loop and check every cell exhaustively. So you got it. In question 2, okay, let me explain question 2. Okay, question 2, it's a lot of words, it's super confusing, but let's get to crux of what it's asking for. So you're given 2 things, right? You look at this example. You're given 2 things. You're given a list of points and you're given a string. Okay? The string are basically the names. Each point has a name. So the first guy is A because the first one is A. And then the second point is B. And then D, C, A. That's the relationship between the points and the string. Okay? That's what the string is doing. Okay, so what you're supposed to do? What you're supposed to do is you're supposed to find a square, the largest possible square that contains as many points as possible, but it doesn't contain a duplicate. Now, what do we know about the squares? The square is centered at 0, 0. This is very, very important. And it has edges parallel to the axis, and it doesn't contain 2 points with the same tag. So for instance, in this case, this square has A, right? So it cannot go out. This is the largest square, that you can go. Because if you go out one more time, if you increase the size of the square by 1 to here, it's going to contain a second A. If you increase the size of the square any larger, it will contain 2 A's, which is illegal. Okay? So that's the rule. The square is centered at 0, 0. And it cannot contain 2 points of the same tag. It cannot contain 2 A's or 2 B's or 2 C's, whatever. Right? So what you can do, what you can do basically is sort of grow the square. You start from 0, 0, and you make the square bigger and bigger. And you see how far it can get before it contains a double point. Does that make sense? So that's your basic strategy. And I'm going to let you figure out, how to actually turn that into code yourself. You see, any other questions? No questions. Okay, so give it a try for number 2. Number 2 is not it's not hard. It's really not hard. So give it a try. If you still get stuck, make sure to let me know. I'll come and help you. Any hints for first? Yeah, nested for loops. Just do nested for loop. The idea is to check every single point in the grid. Yeah, question 1 is not super difficult. And I'm going to go through all of this at the end. So don't worry if you didn't get it. So one hint, I don't know if this is helpful to anyone. It was helpful to me. One hint for question number 2 is that m and n is only 10. So you can just do a for loop from 1 to 10. M and n. Oh, sorry. What am I saying? M and n is not 10. M and n is 10 to the power of 5. So you can't do that. Oops. Yeah, scrap that. Huh. Send code for first? Yeah, sorry, I can't. So we don't share code in this channel. But basically for first one, what you do is you do a nested for loop. And you use the nested for loop to go through all the cells in the grid. And then for each cell, you just check their condition. You check whether the condition is true or not. So I hope that's should be enough. If not, then stick around to the end of contest, and we will share code after contest ends. So for question 2, yeah, you can look at the diagram. So the idea is you sort of your square, right? Your square, the rules is 1, it has to center at 0, 0, and 2, it has to it cannot contain 2 points with the same tag. So you keep you test like, the first one, then the second one, and third one, and you sort of increase the size of the square until you reach a point where you see the same tag being repeated, then you stop. So that's the basic strategy. So one thing you can do to optimize that is you don't have to go through every single value of the length of the square. You can just sort the pairs by their size, by their distance. Let me see what other questions. Yep, no questions so far. All right. Yeah, everybody is deep in thought. I hope everybody is deep in thought. I hope everybody is. Yeah, there are 70 people in live chat. Welcome. Welcome to everybody who just joined the stream. Remember, if you have questions, ask in the chat. If you need a hint, if you're not sure what the question is asking for, also ask in the chat. I will try to help you to the best of my abilities when I can. Huh, interesting. Let me see the chat. Help me by giving. So B hint, Rohan Sharma except for base cases. What are the other conditions? Okay, so B hint. One more time. I can't come back to this. So one more time for people who need hints from B. So the rule is you're given two things. You're given points and you're given S. S is basically tells you the name of the points. Every point has a one character name. It's A, B, C, D, or whatever. Okay? So the idea here is you want to grow your square. You want to keep growing your square. Your square starts with length size 0 at 0, 0, and you want to keep growing your square until you see 2 points with the same, until it contains 2 points of the same letter. So your first at the beginning of your square is just like 0, 0 is a dot. Then it's a 2 by 2 square, and then it's a 4 by 4 square, and you keep growing. And every time you count how many points this new square will contain, and you check whether the new points that are added to the square contains a duplicate. If it contains you're trying to add a point where the tag already exists, then you cannot grow your square anymore. Then you stop. So for instance, this case, you grow your square become bigger until it becomes like this red square here. It contains A and it contains B. You cannot grow it anymore because when you grow it one more, it's going to contain this second A, and that's not allowed. Right? So that's the basic strategy. You can make that a little bit faster by sorting the points based on their how far they are from 0, 0. So if you need more help, I'm going to go through that at the end of the contests. Yeah, I hope that was helpful. If you need more help on question 2, I'm going to come back later in a bit, or come back at the end of the contest. So I need to work on the other questions first. So given a string S, you need to partition it into one or more balanced substrings. If S equals A, B, A, B, C, C, then A, B, A, B, C, C. A balance is called the same number of times all valid partitions. Okay, for question 3, I think I'm going to try a greedy algorithm. That's my first instinct. I think greedy algorithm works for question 2. Question 3. Okay, I see there's a request for question 2. Let me go back to question 2. Because I don't want to leave you guys behind. All right, let's do it one more time. Okay, so question 2 is maximum points inside the square. You're given 2D array points and S. Okay, you're given two things. You're given a list of points and you're given S. So the idea is S represent the names of the points. So here there's points. There are 5 points. And these 5 points are called A point. Second point is called B. Third point is D, C, and A, respectively. So that's what S and points do. So the idea here is you want to form a square that contains as many points as possible. But the square, as many points as possible, it does not contain 2 points to the same tag. Right? It does not contain 2 points to the same tag. So the way to do it, oh, I just lost it. Great. The way to do it is to think about this. The square always starts from 0, 0. Its center is 0, 0. Okay? This is very important. So what you want to do is you start from 0, 0. You imagine the square is just 0 by 0. It's the smallest possible square. And then you see how many points does this square contain? No points. That's all good. Let's see this 2.2 square. What does it contain? Now it touches this B over here, right? So you have B. So you have seen equals B. Okay? And then you go out one more time. You see this A over here, right? You have seen A also, right? And then you go out one more time. Okay? And now you see a C, which is fine, the C over here. But you see this A over here. Oh no, this A is bad. Okay? So this third level is bad. So you have to undo. You have to go back. Undo. So you go back. Only A and B. Okay? So you undo. The third level is not okay. Right? That's the basic strategy behind it. Does that make sense? Let me see the chat. Does that make sense for people? No. So scientific coder, you're talking about question 2, right? Yeah. So no. So there are things that you can do to optimize it. So one way to do it is actually not n squared. It's like it's actually, so if you do it naively, what you do is you'll be O L, where L is the size of the grid, and the grid is very large. So you don't want to do it that way. So you can actually do it smarter. There are two things you want to observe. Okay? I'm going to be quick because I need to go back to my own contest. One is you observe that you can sort the points. By how far they are, from origin. So you want to start with the points. You want to sort the points based on how far they are by origin. 2 is you don't care about both coordinates. You only care about the larger coordinate. So for instance, you have a point that is like 100. Okay? You only care about 100 because only when the square grows to radius 100 would you contain this point. So only larger coord matters. So basically what you can do is you take all the points, you sort them by their larger coordinate. So this is 3, minus 3, 1, right? You know, you take the absolute value of minus 3, which is 3. So this point C, for instance, at minus 3, 1, it will only go into the square if the radius of the square is 3. Does that make sense? So the first step is to transform all these points. You don't need both points. You just need the absolute value of the larger of the two absolute values. That's how far they are from the origin. And then you sort them. And after you sort them, you get 2 arrays. One is how far away are you from the origin, and 2 is what is your letter, what is your name, right? And then that becomes much easier. Then it becomes an ON, basically an ON algorithm. I hope that makes sense. Yeah, I hope that makes sense. So go for it. Unfortunately, I had to focus on my own contest, so I will not be able to explain any more question 2s. But if you still need help for question 2, let's talk about it at the end of the contest, all right? Okay, let me just take a look at the chat. I can't get past question 1. Can anyone provide code for question 2? So unfortunately not. We don't share code during the contest. It's still a contest, right? You're supposed to be competing, and you're not supposed to like share answer is cheating. And LeetCode is actually really strict about this. So they'll ban you, and they might ban me. So please don't share any code on this channel. I will go through all the answers at the end, right? So hang on to your hats. If you can work it out, let's figure it out. So 450 test cases pass, rest failing. Question 1. Question 1 is not tricky, but you may have a bug in your code. So if you're okay, let's wait until the end of the contest. And then if you sort of send me your code somehow at the end of contest, not right now, we'll go through it and try to debug it together if you want. But question 1 is not supposed to be tricky. It's supposed to be just one nested, 2 nested for loops, and go for it. So question 3, hints on question 3. I'm still working on question 3. So the way I'm tackling this is basically, I'm just going greedy. I'm just going to go from 1 until the end, and I'm gonna see. I'm gonna find the longest string I can. Where I'm going to go try to find the longest string that I can that is balanced, and then I'm going to stop and I'm going to do it again. And I don't think it's super fast. I think it's a n cube or something. That's my strategy. But because s length is very short, it should be fine. So the idea is, you try and be greedy. You try to find the longest string that you can make it balanced. Yeah. I hope that helps. Unordered set in question 2. I didn't use an unordered set. So you can just... So the trick in question 2 is realize that even though it's x, y, if you want to know whether it's like if you follow the same strategy that I was talking about, where you have these boxes that keep growing larger and larger, right? If your box keep growing larger and larger, you only need to care about how far you are from the distance, and how far you are from the origin depends on the larger of your 2 coordinates. You don't need both x and y. You need the larger one. So for instance, this c, right, c is -3, 1. So the distance between C and origin is actually 3. You can ignore the 1. And you can ignore the minus. So you take the absolute value. You take the absolute value of your x and y, and you take the larger one. So that's the distance, right? And so you want to sort of increase the size of the square until you find a duplicate. And then you're forced to stop. Yep. So Satyam Raj, yep. That's pretty much it. So you take max of absolute x, absolute y, and then you sort them. Remember, you in a list along with this tag. Yeah. So you combine it with the tag, and then you sort the whole thing. And then you see how far it can go until you see a duplicate tag. The only thing you have to make sure is if you have, like in this example, you have this A. This is a tricky example. You have an A here, and then you have a C here, right? You have an A and C. So the only tricky thing is when you increase your square to here. If you add the C first, and then you add the A, and you realize that you can't add the A, you have to take out the C. So that's the only slightly tricky thing that you need to do it. So I'll explain what question 3 is. Sure, no problem. So you're given a string S, you need to partition it into one or more balanced substring. So for instance, S equals ABABCC, then all these are substrings. And all these are balanced. Okay? So a substring is basically you chop them up into pieces. That's very straightforward. They have to be contiguous. You cannot pick and choose. So balanced just means that you have the same number of each character. So if you have one, if you have let's say for this one, right? A, B, A, B, C, C, right? You have 2 A's, 2 B's, and 2 C's. So that will be considered balanced. Whereas something like BAB, so BAB has 2 B's and 1 A. So this will be not balanced because there's the number of A's and the number of B's is different, right? So that's the definition of balanced. So for instance, in this case, you know, FAB, there's only one copy of F, so the only way to balance it, literally the only way to balance it is just to have exactly one copy of F. So A, B, and F, A, and B, that's FAB. So this is balanced. And then C, C, D, D, this is balanced also because there's 2 C's, 2 Z. And G by itself is going to be balanced because it's only one item, right? It's always going to be balanced. Yep. So the way I'm doing it for this one is I'm trying greedy right now. I haven't finished my work because I haven't finished my question yet, so I'm still working on it. So the way I try to do it is I find the longest balanced string. I go through the entire string and find the longest balanced string. So this is the longest balanced string starting from 1. And then I'm like, I get rid of these guys. And now I find the next longest balanced string. So which will be here. And get rid of this guy. I think it will work because even though it's very slow, the size of S is only 1000. So I'm hoping it'll work. Yeah, I think my algorithm might be n cube, which is super slow. But you know, hopefully because it's 1000, it's gonna work. S is only 1000, it's gonna work. Okay. Let me just look at the chat again. Hint for question 3. Yes. Give me a second. Question 1 logic. I can't go through question 1 right now because I've done it a lot of times. Sorry about that. but I will go through question 1 and 2 at the end. Second question. Test. Using set for check. How to use string and point simultaneously in CPP. So swastic. So the way to do it, there's two ways. One is either you... I think the best way is to make a list, like a vector of vectors. I don't remember if C++ has a pair, has a std pair. You can use std pair if you want. If not, you can use a vector of vectors. Yeah, Rupesh done for the day. Hey, look, don't worry about it, right? It's your first. Yeah, CPP has pairs. Yeah, so you can use C++ std pairs. Or you can use a list of lists. I would use a list of lists because I'm super lazy. A list of arrays. Let me see. Time limit for second question. Okay, time limit for question. Great. I will go through that later. Yeah, so Rupesh, don't worry too hard. This is your first contest, right? You solve one, that's good enough. This question 2 is not. It's harder than a lot of question 2s. It's not that hard, but it's harder than most question 2s. Okay, so concar, let me check the third test case. Yeah, I don't know. I might be wrong. So A, B, A, B, A, B. Oh, interesting. I think you're right. So greedy doesn't actually work. Greedy doesn't actually work. Yeah. Yeah. The second case says you cannot use greedy. Interesting. Let me think about it a little bit. Yeah, so greedy doesn't actually work. Is there a way to tell if the rest of your substring partitions? There's no easy way to tell if the rest of your substring partitions neatly into one or more balanced substrings. Because it always partitions into a balanced substring, right? All strings can become balanced substring. You just, partition one letter at a time. That's automatically balanced. Yeah, recursion. Let me think about it a little bit. Yeah, that's a good point. Thank you for the call out, Concar Takia. So you basically need to do AB, AB, and you cannot do the last AB because you need this A and this B to support these guys at the end. I guess maybe some kind of dynamic programming problem? Some kind of dynamic programming? Let me see. Oh, maybe it's some kind of dynamic programming. Yeah, maybe it's some kind of dynamic programming. I wonder if it will be too slow. So here's what I'm thinking. So A, B, A, B, A, B, C, C. Oh. A, B, A, B, A, B, A, C, C, D, D, B. Okay? So maybe some kind of dynamic programming. So for instance, I know that if I were to go, oh, okay, I think I got it. So I know, let's say I just look at the first one, right? The first one is a balanced string, and its cost is 1 because it takes 1, because you can divide it into exactly one balanced string. The second one, AB, is also a balanced string, so it's sort of best case scenario is also 1. So third one is 2, because the best way you can divide ABA is you have AB and then you have an A. So the fourth one is also 2, because the best way to divide AB is like AB and AB. Okay, cool. So you sort of find the best possible answer at each point. And so when you reach here, what you want to do is you want to check maybe you go backwards. Let's say I'm here, right? I'm at this A here. Let's say I ignore this. Ignore the rest. I pretend all these things don't exist, right? I ignore the rest. Let's say my problem is only up to here. How do I calculate what's the best arrangement for A? Well, either, so this is dynamic programming, right? Either I start a new partition with just myself, in which case it will be 1 plus the guy before me, or I form part of a longer balanced string. So from here, I sort of go backwards and see what balanced strings I can form. So let's say I'm here, right? I know the best possible division of balanced string for everybody before me is 1, 1, 2, and 2. Okay? So I'm here, right? There are 3 options for me. There are 3 options for me here. Option 1, I have a new balanced string. And the cost of this option is 1 plus dp 3. 2, I find a previous balanced string I can be part of. So the last balanced string I can be part of is I can be BA, in which case is 1 plus dp2. Yeah. Or 3, I can be BA, Baba, I can be this one, in which case my cost is 1 plus dp of 0. Does that make sense? I feel like that should make sense. Okay, so Do Dragon, 1 example 2, 1 is not the answer. In example 2, 1 is not the answer because you look very carefully. There's one. Wait, let me see. Oh, yeah. So 1 is not the answer because if you take the whole thing, there will be 1, 2, 3, 4, 4 A's, 4 B's, 2 C's, and 2 D's. So the number of CDs and the number of BAs are different. So a balanced string, yeah, a balanced string needs to have the same number of every character is the same number. Okay, I think this is I think this is how it's gonna look, right? So you sort of do DP, and what you do is at each place, what I'm going to try, I don't know whether this will work. I'm going to look at all the balance strings I have in the past. All the balance strings I have in the past. And then based on that, I'm going to see what is my sort of like best. I think there are slightly faster ways of doing it. But I'm going to try it first, see if I'm going to get a timeout. So this is going to be my basic idea. I'm going to do a DP array. At each point, my DP is I'm going to check all the possible balance strings I can form. So the trivial case, I can form a balance string with just myself. Let's say I'm here. I'm at index number 4. I can form a balance string with just myself. And the new cost will be 1 plus, which is the new balance string, plus DP of the index before me, DP3. I can also form a balance string BA, which means in which case the cost is 1 plus DP2. Yeah, I'm going to try this. I'm just going to see whether it's work. Yeah. Yeah, damn it. So unfortunately, the greedy doesn't work. Alright. Let's try it out. Okay, let me see. The cos of AB will be 1 in the diagram I made. Yeah. Oh, yeah. Correct. Damn it. You're right. The cos of AB is 1. Yes, exactly. And then cos of this A is actually going to be, I guess it's going to be 2, right? Because its best will be this one. It's dp3. dp3 is AB is 1. And so 1 plus 1 is actual cos is going to be 2. Yeah, so good catch. Yeah, good catch, Swastik. Sorry. Yeah, sounds like everybody is stumped on question 3. Everybody is stumped on question 3. Okay. Okay. So I ran it. I think this method will work. Hopefully no TLE. Oh, it works. So I got it to work. Yeah, so you can use DP like exactly as I described here, and it should work. I'm programming in Python. If Python is fast enough, you C and Java people should be even faster. So you have questions about question 3? Let me know. Just ping in the chat. I'll try to help. Hopefully question 4 is not too difficult. Powerful array for an integer x is the shortest sorted array of powers of 2 that sum up to x. Shortest sorted array of powers of 2 that sum up to x. Powerful array for 11 is 1, 2, and 8. Oh my god. Big nums is created by concatenating powerful arrays for every positive integer in ascending order. 1, 2, 1, 2, 4, 1. Given 2 this. Calculate big nums times. Oh my god, I hate these math questions. Query I equals from to mod. Big nums from. With big nums by mod I. Okay, interesting. Okay, question 4. Isn't this just a prefix sum? What the heck? Oh, because this number is very big. Is it very big? Queries the length 500, yeah? Oh, it's 10 to the power 15. To the power 15. Okay. Okay, yes, please 3. Please question 3. Yeah, do you guys want me to go through question 3 again? So question 3, I think I got it using DP. Yeah, let me go through question 3 again, okay? Let me go through question 3 again. So for those people who didn't catch it the first time. So the thing to understand, first, let's quickly talk about what the question is asking. You're given a string, let's say A, B, A, B, C, C, and you want to split it into balanced partitions, right? Balanced substring. The substring is basically contiguous. So you cannot pick and choose. You have to, cut it, chop it up into pieces. Chop, chop, chop. Dismember this guy. So what does balance mean? Balance means that all the letters that appear inside that substring appear the same number of times. So for instance, A, B, A, B, C, C, right? There are 2 A's, 2 B's, 2 C's. So this is balanced. B, A, B, there's 2 B's, 1 A, not balanced. Letters that don't appear, you don't care. If they're 0, you don't care. Okay? So that's what balance means. So your idea is you want to chop this big string up into a bunch of balanced substrings. So the basic strategy that I'm using is some kind of DP. It's some kind of dynamic programming. So you think about dynamic programming, right? You sort of create a DP array as long as the string and the number you put here is the minimum number of substrings you need to partition if that string was this letter long. So for instance, this number here, let me just pick a different number. This number here, 2, means that if S was A, B, A, B, A, I need to partition it into a minimum of 2 balanced substrings. That's what this number means. Okay? This is very standard DP idea. This idea is very standard in DP. What you want to do is think of the basically you want to solve the problem incrementally in DP, right? The answer for n I equals to n is based on the answers for values of I smaller than n. So that's the basic idea. So what is the answer for this guy? Well, there's only one way to partition him, right? So his answer is 1. If S is only A, then his answer is 1, right? If S is A and B, what happens? Well, there's 2 ways to partition. Either you take the whole thing, and since the balance string is also going to be 1, okay? If S is of length 3, A, B, A, what's the best way, smallest number of balanced substrings you can cut this up to? You can do A, B, and A. So the answer here is 2, right? This is A, B, and A. So that's why it's 2. Okay, and so on and so forth. Now, what happens at I equals to n? Let's say I equals to 4, right? At this place. When you reach I equals to 4, what's the minimum number of balanced substrings that you will need? What's the minimum number of partitions you have to make in order for each partition to be a balanced substring? Well, let's say you don't know this answer. Well, you have a few possibilities, right? In fact, you have the first option you have is you can just make A a new string. So the new string will be A. Since there's only one character, it's always going to be balanced. What's the cost of this action? Well, it's going to be 1, which is this new string, plus dp of 3. Because your new string is going to be A. The cost of cutting up this entire array is going to be 1, this new string, this new partition, plus the best possible partitioning of A, B, A, B. So this is 1 plus dp3, which is the number here. And that gives you 2. What's the other option you can have? Well, the other thing you could do is say, hey, instead of making A, this new A, its own string, I'm going to go back. I'm going to find any sort of balanced substrings I can use. So in this case, BA is a balanced substring, right? BA is a balanced substring. So another option I have is 1 plus dp2. because if I'm going to make my new partition BA, its remaining characters are going to be ABA. So it's 1 plus DP2. Does that make sense? And then what's the other balance substring I can make with this A? The third balance substring that I can make this A is BABA. In this case, it's again 1, which is the new balance substring, plus DP of 0. Plus DP of 0. Does that make sense? Yeah, I hope so, because I've really gone through this problem at this point. You ruin the hard work of those who are giving by themselves. Yeah, well, that's why we don't show code, right? So we never show code. You have to figure it out. So if you want some hints, you have to write the code yourself, basically. Yeah. So I try not to give like very obvious hints. Yeah. But at the end of the day, you still have to write the code yourself. So, you still have to go through that process of doing that programming. Memoization array, yeah. You don't need, so Piyush, you can do it either recursively or iteratively, it's up to you. But it's basically a DP problem. Yeah. But Yash, I think what you said is a fair point. I'll think about it. I can definitely reduce the number of hints that I give. So notice I never give any code, right? I don't write any pseudocode. I just explain using pictures. So maybe in this case, you might argue that this is a little bit more information than normal in like a really competitive contest. But you do make a fair point. So I do agree with you. Yeah. Yeah, but at the same time, I sort of do value learning, and I just want to help people learn. And also the other thing I have to say, one more thing in my defense, is that I actually suck at this. As you can see, my rating is not that high. It's not like I'm the champion and I'm contest winner. I'm giving away my answers the moment I solve them, right? I also struggling. So people who learn from my channel is not exactly going to affect the leaderboard in any way. It's not like we're cheating and winning prizes. None of us are winning any prizes. Okay. So you solved the one by using your hint. Excellent. Great. So make sure you work on them yourself. Don't share code. That's the rule that we have. Don't share code. You can give hints. Yeah. And I can consider thinking about giving less obvious hints. We can just say, oh, this is a DP. Think about it yourself. But at the end of the day, LeetCode also want people to learn something from the process, right? If everybody just cannot even solve one problem, then that's probably not helpful to anyone, whether LeetCode or its participants. But yeah, I don't think anyone here is like a serious leaderboard contestant. If it were, then it would be very unfair. I agree with you. Yeah. The contest can't solve over one question. It's fine. No worries. My first contest, I did 2 questions very quickly, and then I was stuck. And I was like, oh crap, this is insanely hard. Yeah, the contest is not that easy. So question 4 is interesting. So it's basically a binary number, essentially. You're converting them to binary numbers. Big nums. Yeah, you're converting them to binary numbers. In fact, let me think about it a little bit. No, you can also live stream the contest. You're beneficial. Yeah, yeah. I mean, I think you're right. So again, that's a good point, right? I'll think about it, and if you want to talk more, definitely comment on the video, or you can send me an email. But you're right. Basically, I think you're right. But let me think about it. But at the same time, if you look at what's in the chat, I think it is beneficial to people. You're helping people. Yeah, and again, it's not like because of this, we suddenly become contest winners, right? Nobody here is winning contests. I'm not winning contests. So I don't think anybody who's like that serious about the ranking is going to be affected. But yeah, again, if you want, I do think Yash, you have a valid point. If you want, you can send me an email. We can talk about it more. Yeah. Ah. Okay, contest 7 minutes left. I hope everybody is trying your best. Yeah. Yeah. No, yes, I don't think you're crying at all. I do think you make a valid point. Let me think about it a little bit more. Because at the end of the day, I think everybody, I'm also part of the LeetCode community. I want what's best for contests in like competitive integrity. I really value that. I also value educational value. So I want people to learn. That's the other goal I have. And I'll think about it. My sense is that the problem with these videos afterwards is yeah. Okay, sorry. Let me talk about it later. Kanesh Yatra. Yeah. Okay. Yeah. Yeah, but because if you release these videos afterwards, people sort of, it's like you learn in the moment, right? If the moment has passed, then you don't feel as excited to learn from it afterwards. Yeah. Okay, so I'm also thinking about question 4. I think so far, so a powerful array for x is a sorted array of powers of 2 that sum up to x. For instance, powerful array for 11 is 1, 2, and 8. The array big nums is created by concatenating powerful arrays for each positive I in ascending order. Okay, so big nums is this, right? All these are going to be powers of 2. In fact, if you think about it, they are actually binary numbers. Right? They're actually binary numbers. And so this would, this will give you 1. This will give you 2. This will give you 1, 2. And then this will give you 4. This is super interesting. This will actually give you 1, 4. Because it sort of skips. There's no 2 here. So this is kind of odd. And this will give you 2, 4. Yeah, so I don't know. I'm pretty stumped. I think the trick here, so one thing you can think about is you can do it naively, but if you do it naively, you're going to fail. Because this big num is like really big. The queries are up to 10 to the power 15. There's no way you can do it naively. So essentially what you probably want to do, the way I'm thinking about doing it is, like, I want to estimate, let's say for query 100 to 200, I need to know what number this corresponds to and what number this corresponds to. Yeah, that's what I'm thinking right now. To find out what number this corresponds to, I basically have to know, for the sum of all the this thing is actually the length of this, right? It's the number of 1 bits in the binary representation of that number. Yeah, so that's what I have so far. I don't think I'm going to. Yeah. So that's what I have so far. I don't think I'm going to be able to finish 4 within the last 2 minutes. Yeah. Actually, I'm curious what other people think about Yash's point, to be honest. Sorry, I'm so fixated on this. Because I do think Yash, you raised a very good point, and I'm grateful that you bring it up to me. I'm curious what other people in the chat think. We can talk about it later after the contest ends. For now, people who are almost done, make sure you try to struggle through the last 2 minutes. Time up. 2 more minutes, bro. 2 more minutes. It's like your exam, like I don't know whether they do this these days. In my time, the examiner is very strict. When they say pencil down and you're still scribbling, the proctor will come take away your your test paper. Yeah, so it kind of sucks at the time. 100-minute time limit, yeah. Yeah. Okay, so the contest is almost ending. I do want to take this time again. Small plug for myself. If you enjoy this channel, make sure you like and subscribe. I read all the comments, so if you have questions about this, you want to ask about, even not competitive programming style things, you want to ask about regular software engineering, or you want to ask about what people do as a day in the life of a software engineer, I'm happy to answer those questions. Just post them in the comments. I'm happy to read them, and usually I answer all my emails too. So I'm one more stream tomorrow. No stream tomorrow, so I need to do streams. I stream the bi-weekly contest if it's on. If no bi-weekly contest, I stream the weekly contest, because I'm based in the US, and so my weekly contest is actually for me is Saturday night, and I just don't want to spend all my Saturday nights at home online. So I try to stream bi-weekly contests when I can. The time works out better, and I think the audience, there's a little bit more people watching this also. So give me 30 seconds. I'm going to get a swig of water. We'll come back and we'll go through all 4 questions. Well, all 3 questions. 4th one, I don't know if I have the answer. I'm actually based in the US. I'll be right back. I did grow up in Singapore though, but I've been living in the US for most of my life now at this point. As you can see, it's sunny outside. The time zone is a little bit different from you guys. I think most of you guys are from India. I think one person at least is from the UK. Okay. Let me just pull up the regular contest. It doesn't show. Okay, yeah, I didn't manage to do question 4 also. Well, first of all, congratulations. Yeah, majority are Indian. Congratulations to everybody who joined the stream and worked on the contest. Right, the idea, the fact that you're here, you're trying, you're learning is already a win, no matter what results you get. So I want to emphasize that. I hope that this is beneficial and helpful to your personal learning journey. If you have any comments about my stream or channel, I'm always ready to hear feedback. So email me, just email me, or yeah, that's probably the best way. If not, you can send me a comment in the stream. I read those and respond to those too. Okay, so let me get my usual spiel, because I have to chop up the video afterwards. I need an intro. We are discussing solutions for LeetCode Biweekly Contest 130. Jump to specific questions using timestamps in the video description. If you enjoy LeetCode content, please check out the rest of my channel. And as usual, like and subscribe to stay up to date on new videos. Alright, so today's contest, I think some questions are hard, some questions are easy, so it sort of balances out in the end. I am going to go through all 4 questions one by one to the best of my abilities. So let's get going. First, question 1. Check if grid satisfies condition. You are given a 2-dimensional matrix grid of size m times n. You need to check if each cell grid ij is 1. Equal to a cell below it. Okay, meaning this, if it exists. So if it's on the last row, if it's like on the last row, like here, then you don't have to check. Okay? And then 2 is different from the cell to the right. So grid ij not equals ij plus 1. So same thing, if it's on the last column, you don't have to check. Right? So this question is not that hard. It's basically just do what the instructions say. Right? Hang on. Wait a second. Can I refresh this? Yeah. You do what the instruction says. It asks you check two things, right? Then you check two things. You do a nested for loop. You do a nested for loop. You use your standard ij, range n, range m, right? And for each cell, what you want to check is you want to check that if it violates the condition. Remember, if you check that it passes the condition, no use. If it passes, so what? You move on to the next one, right? So you check that it violates the condition. If n is smaller than n and grid ij not equals to this, so basically you copy all these things here, right? If it violates the condition, return false. Same thing, if j smaller than m minus 1 is not the last column, then check that this thing is, if it's equal, if it violates the condition, return false. Then at the end, you return true. So this is pretty straightforward. You run it, you should submit nicely. Okay, any questions about this? Yeah. Well, Yash, let me think about it. I think, yeah, I have to balance the pedagogy. But let's take this conversation offline. I would love to talk to you more because, you know, you're very passionate about this, and I am actually honestly very grateful that, you know, somebody brought up this topic. But please reach out to me by email. Okay. So question 2. Wow, a lot of pictures. So let's see what question 2 is saying. You're given a two-dimensional array points in a string S. Points I represents the coordinates of point I, and Si represents the tag of point I. A valid square is a square centered at origin 0, 0. This is actually super important. Has edges parallel to it, so it's a square, and does not contain 2 points of the same tag. So the two things you need to know about this square is that 1, its middle is 0, 0. And 2, it does not contain 2 points of the same tag. You return the maximum number of points contained in a valid square. Okay? So the basic idea, I've gone through, I talked about this briefly. The basic idea is you have these larger and larger squares, right? The nice thing about this question is that the square is centered at 0, 0. If the square can be anywhere, then the question is really hard. Well, not really hard, but much harder. But because the square has to be centered at origin 0, 0, it's not that bad. Essentially, what you want to do is to grow the square, right? You start at 0, 0. You see, do I violate any rules? Do I break any rules? The 2 points, the same tag rule. Do I break that? Nope. Okay, keep going. Right? So let me just erase this and repeat this explanation. So I start at 0, 0. I've seen. Oh, okay. I've seen nothing, right? And then I go to 0, 1, still nothing. I now see B. I saw a B, okay? And then I go to radius 2. Now I see A and B, okay? Still fine because I haven't seen any duplicates yet. And now, finally, I go to radius 4. And at this point, I see another A. This A and this A, right? They violate the rule. You cannot have 2 A's. You cannot have 2 points of the same tag. If they violate the rule, then I stop. So essentially, I'm sort of growing the array until I stop. Okay? So that's the basic idea. But here's the thing though. Here's the thing. If you do this naively, if you grow the array one step at a time, you will never finish. Because this A can be 100, 1000, whatever. It's a giant number, right? So the trick here is basically we want to sort the points based on how far away they are from the middle. So I want to sort the point based on how far they are away from the middle. And I want to look at the closest points first. How do I define closest? How do I define closest? This is very interesting. Well, closest, actually, if you think about it very carefully, let's say this point C equals to -3, 1, right? Closest just means how far is it from origin? Its distance is actually 3. Because I don't care about the 1. The 1 doesn't matter. The 3 is the one that matters. I need to grow this square to radius 3 before it captures this point. So you have to grow the square to radius 3 before it captures this point. So its distance is actually 3. So essentially the distance is the absolute value is the larger of the absolute value of x and y. So max of absolute value x, absolute value y. Okay, that's the distance. So with that information, you now don't even need the point at all, right? So what, let me just copy my, so what you can now do is first, I'm going to take points. I don't really need points. I just need the distance. I just need what distance they are at from the origin. And this tells me what's the largest square that I can, how large the square will grow before it contains this point. Okay, so I turn that into distance. So points, I just take, so maximum, absolute value of x, absolute value of y. And what I do, I zip it. In Python, that just means I combine the two lists together. So I combine the two lists together. So for instance, distance 3 and the name of the point is C. So this will be an item in the zipped pairs. So I keep doing, I do this and then I sort them. The next thing I do, I sort them. And this will give me the closest point to the furthest point. And after that, then it becomes straightforward, right? I just have seen, this is a hash set. And I just check, have I seen this before? If I've seen it, then I can stop. If I haven't seen it, then add it in. I add point count plus minus 1, right? So this is the basic idea. So what I will do is I'm going to print out. I'm actually going to use a test case and print out what this list pairs is. So list pairs. Hopefully this is going to be helpful to people. So list pairs look a little bit like this. I have a point A that's from distance 2 from origin. Point B, distance 2 from origin. Another point A, distance 3 from origin. So the thing to note is that I turn the points into basically their distance from the origin and I sort them. And then now I have this set of points plus their distance. I go from the closest to the furthest. I keep going until I see a repeat. So I see this A, right? This A, and there was already an A before. I will stop here. So my answer is going to be 2. So that's the strategy. That's the basic strategy that's involved here. Let me take a look at the chat. Yeah, any questions? Great finance, that was tough. Yep. Yeah. Welcome back, Rate Finance. Yeah, it's Hackers.io. I recognize a lot of you guys. Yeah. How come people solve questions this difficulty in seconds? I have no idea. I really have no idea. So I actually looked at some of the videos that people give. So one of the things they do is they pre-write a lot of code. So they pre-write, let's say, Dijkstra's algorithm. They pre-write like nearest neighbor sort or whatever, and then they just keep it in their own computer, right? And then when they need to, they just grab it and they copy paste. So that makes it a lot faster. And anyway, it's their own code, so it's definitely not cheating at all. So they just sort of pre-write common algorithms. And besides, a lot of languages allow you to do that. Okay, so question 3. Question 3 is an interesting one. So I'm going to spend a little bit more time on it. Since I think let me see quickly. So quick show of hands. Who actually got question 3? I think a few people got question 3, right? So it's pretty cool. Yeah, some of you got TLE. Okay, so that's fine. Okay. So question 3, let's talk about it. You're given a string S, you need to partition it. So question 3, minimum substring partition of equal character frequency. You're given a string S, you need to partition it into one or more balanced substrings. So for instance, partition just means chop it up. So for instance, A, B, C, C. All these are possible ways of chopping them up, and all these are balanced substring. What is a balanced substring? A balanced substring is just a string where every character in the string appears the same number of times. So for instance, A, B, C, C. There are 2 A's, 2 B's, and 2 C's. So this is balanced, right? On the other hand, something like ABA, there are 2 A's and there's 1 B. So this would be not balanced. That's the meaning of balanced. Okay. So let's look at some examples. So in this case, FAB, CCDDG. How do you chop this up into balanced substrings? Well, one way you can do it is FAB. FAB is balanced. There's 1 F, 1 A, 1 B. So it's kind of balanced, right? It's kind of balanced in a like a weird kind of way, but it is balanced. 1 A, 1 B, 1 F, right? So this is balanced. C, C, D, D. 2 C's, 2 D's. This is also balanced. And then G. Any character by itself, it's going to be balanced. There's only one. Right. So this is one way of doing it. And let's look at this one. This one is quite interesting. So this is A, B, A, B, A, B, A, C, C, D, D, B. Okay? So when I first looked at this, I thought, oh, you know, you can take this, and then you have to take this, and then this, and do all kinds of stuff. So I was a little bit stumped at first and how to chop this up into the minimum number of balanced substrings. So it turns out that the way to do it is actually to do something like this. A, B, A, B, and then A, B, A, C, C, D, D, B. This is balanced also because there are 2 A's, 2 B's, 2 C's, and 2 D's. So this is how you balance these this example too. Okay? So now that you understand what the question is asking for, how do you go about solving it? How do you go about solving it? Whenever you see a long list or string or something like that, generally, not generally, but often they will involve some kind of recursion. They will involve some kind of dynamic programming. And I think this is one of those cases. So how would you solve something like that? The way dynamic programming works is that you want to start with a base case, and for every like n equals I, you want to calculate the answer for n equals I using the answers from n equals numbers smaller than I. Okay, let's take a look at what this means for this question concretely. Okay, so let's take a look at this guy right here. Actually, before that, let me address something. So the first thing I actually try is to use a greedy algorithm. The greedy algorithm says I'm going to grab as many balance as the longest possible balance substring I can, and then go from there, right? That actually fails on this guy because you're greedy, you'll grab this, and then you're stuck. The rest of this one is doomed. So greedy doesn't work. Instead, what you can do is you can use a dynamic programming to help you. So let's do this FABCC. Let's say this is your input, right? So what you want to do is to construct a dynamic programming array, where the dynamic programming array, each cell represents that answer for that length. So for instance, if S was just F and nothing else, right? If S is just F and nothing else, you sort of like cover the rest, right? Then the answer is going to be 1. There's only one way to partition F, and it's 1. If S is just F and A, the answer is also going to be 1. FA is a balanced substring. And because FA is a balanced substring, you can you can essentially just do 1. Okay, same thing for B. So FAB is a balanced substring. So the number, the sort of best minimum number of balanced substring you have divided into is still 1, right? Same thing for this C is still 1. This C is going to be, and then you keep going, right? So that's the basic idea, is you want to make it such that DPI, the answer for DPI, is the answer for if S was at that length. So what do you do at DPN? Let me switch to a different color. So let's say the index 1. Okay, what do you do when n equals to 4? Well, if you don't know the answer for n equals to 4, there are 3 possible options. 1, you can make your new substring C, and the cost of that will be 1 plus dp of 3, right? Because C, this new substring C, just one character, is always going to be balanced. And the cost is going to be 1, which is the new string, plus the cost of whatever before. Because we already know, we assume, the dp contains the answer for whatever is before. So dp3. Or, the other thing you could do is to say, I want my new substring, my new balanced substring containing index 4 to be cc. In which case, the answer is 1 plus dp2. It's going 1 plus dp2, right? If this is my new balanced substring, then the answer here is going to be 1, which is this new string, plus whatever answer is here, right? Because this dp value tells me the best possible result from before. So to make it more generalized, basically the value of any dpi equals the minimum of all the possible candidates. And what are candidates? Basically, you look at all the possible substrings ending with I that are balanced, and then you add 1 to the dp value before it. So this is balanced, you add 1 to this dp3. This is balanced, you add 1 to dp2, right? And you find the smallest number from that. Okay, and then you keep going until you reach the end. So this is actually much faster. I think it's still n squared, if I'm not mistaken, but because n is a very small number in this case, it doesn't make a difference. Okay, so this is what it looks like. Okay, so I'll show you the answer in code. So in code, this is what it looks like. It's not very long, surprisingly. So what I did is let me just check if there's any questions in the chat. Yeah. Sorry, I kept talking. I didn't look at the chat. Third one got me TLE. Yeah, we'll go through the answer. So Siddharth, Saurav, did you use DP or did you just use brute force? You stack to greedy? Yeah. So greedy, actually, I did the greedy one first, and then it failed on the second example. So second example, you cannot use greedy. Efficiently balanced string. Yeah, that's the easiest part. It's not the easiest part. It depends on your language. It's actually, there are tricks that you can use. Greedy algorithm can be used to solve problem, but you traverse from start to end, and end to start, you can run it. Yeah, so greedy, I thought the greedy will work also. That was my first instinct also. In fact, you can see this is the greedy version, and then it failed on this guy. And after it failed on this guy, and someone actually pointed that out in the chat. Before it failed on the at the same time it was failing, and I realized that that greedy doesn't work. Yeah. Second question took me a lot. Yes. this second question is hard for question 2. It fails for test case. Yeah. Okay, so this is how the code looks like if you care about it. I define a sub function called balanced, and the way I did it in Python is very simple. You just take basically you take all the numbers, the d dot value. D is a dictionary of how many times something occurred. So I take all the occurrences, so d dot value. I make it a set, and then I check that the length of the set is 1. So this is some like Pythonista. It's quite fast because essentially what it does under the hood is that it does set insertion, which is fast. Yeah. Actually, I think it can be faster, but whatever. Okay, so this is the DP array I just described. 1 to n. So DP 0 is going to be 1. And then for each I value of I, what I do is I go backwards. So same thing as here. I go backwards. I find all the balanced substrings I can make going backwards. So C, if I'm here, the C is balanced. So this is one candidate. And I go backwards. CC also balanced. This is another candidate, CC. And I go backwards, BCC, ABCC, FABCC, all doesn't work. So CC is the best. C and CC are the best I have. And then what I do is I will, I just go backwards. I just check, is it balanced? If it is, then if it's at 0, then the whole thing is balanced. That's great. Best is 1. If not, then best equals to min best 1 plus dp j minus 1. Yeah. So I add the dp from the previous value, and then I return the last item in the dp array. Yeah. So that's Okay, any questions? Yeah, so the maximum number of 26 characters in D makes it a little bit better. It just makes it a little bit better. Actually, I was thinking of how to optimize it by as I go through the array. It's probably over-engineered, but there are probably ways to make it even faster. But this one is fast enough. Okay, any questions? If not, then let's go through the last question 4. So question 4, I didn't manage to get it. Let me see, find products. I'll talk a little bit about what my thinking is at. Okay, I'll explain the question and explain where my thinking is at. But I didn't manage to solve the problem. So if you did, then congratulations. That's great. Post in the chat and I'll be excited to I'm always excited to cheer for people who do well. So it says here, a powerful array for x is the shortest sorted array of powers of 2 that sum up to x. For example, the powerful array for 11 is 1, 2, and 8. The array big nums is created by concatenating the powerful arrays for every positive integer I in ascending order 1, 2, 3, and so forth. So big nums is this. So let's start by demystifying this. What is this sentence trying to say? A powerful array for x is the shortest array of powers of 2 that sum up to x. Basically, you look at it carefully, it's a binary representation. The binary representation of 11 is, so 11 in binary equals to 1, 1, 0, 1, 1. So this 1 is 8. This 1 is 2, and this 1 is 1. So 1, 2, and 8. This is binary representation. Yep. And it's kind of weird that it says shortest sorted array of powers of 2. There's only one possible combination of powers of 2 that add up to any number. So, it's not exactly the shortest. So next, the array big nums is created by concatenating powerful arrays for every positive integer I in ascending order. So big nums is 1, 2, 1, 2. So this one corresponds to 1, this one corresponds to 2, this is actually 3. 1 plus 2 is 3. And then 4, and then 1, 4, and then 2, 4, and so on and so forth. And so you're given a 2D matrix queries from, to, and mod, and what you want to do is to calculate big nums multiplied by this all the way from to 2. So the main constraint here, so when you look at this, you know, when I looked at this, I thought, oh, can I just calculate the whole sequence? Well, the answer is no, you cannot calculate the whole sequence, because queries I, the queries are of up to 10 to the power 15. So I cannot calculate a sequence that is 10 to the power 15 long. It just TLE right away. Yeah. Even with a supercomputer, I think. Yeah, it's a very big number. So essentially, what I think is you need to estimate what's the length at any given n. So for instance, this sequence ending with 1 is of length 1. Sequence ending of 2 is of length basically 2. Sequence ending of 3 is of sequence 1, 2, 4. Sequence ending of 4 is 1, 2, 3, 4, 5. So essentially, the length of the sequence, you know, okay. So eventually from length, so the what I'm thinking of is the length of big num I equals to some function of I. I need to calculate the length of big num I based on the function of I. So if I can do that, that will help me a lot. That will help me a lot, because then I know like Q equals, the query is 100 to 200, let's say. Then I need to know what I is, and I sort of jump to that number right away. Yeah. So you think about this F basically is just the number of 1 bits. The number of 1 bits in that binary number. So I think when I equals to 2 to the power of x, length of big num, I equals to, I think it's 2 to the power of I, if I'm not mistaken. Yeah, I have to think about it a little bit. 1, 2, 3, 4, 5. I guess not. Yeah, there's some relationship between the two. So I need to figure that out. I think that's the strategy to solving the problem. But either way, unfortunately, time was up. I was not able to complete the whole thing. I did manage to get 3 columns. It's not, you know, I think it's a fairly average result by my own personal standards. And again, you know, don't be intimidated by people who complete in like crazy amounts of time. That's not the point. The point is to compete against yourself, become better each time. And if you learn something from the contest, then you are a winner. Okay. All right. Only difference in confident values to list and check all the values are the same instead of set length method. Yeah. Yeah, so the thing about Python, for ChannyPy, something I learned about Python is that Python is very freaking slow. So the less Python code you write, the faster it is. Like my code actually runs, if you look at my code, it's not efficient. My code is very stupid. It's not efficient, right? Yeah, this is not efficient at all. If I'm doing this set, it means that I will always check every single item in this d.values thing. Whereas if you just do for, you know, x in d.values, and then if x not equals blah blah blah, this will break halfway. This will stop halfway. When you find something that is not the same, it'll stop right away. But this can be slower because if you write the for loop will be in Python. Whereas a lot of these like basic set functions, they are written in C. A lot of Python libraries are written in C. And when they are written in C, they are infinitely faster than any code you write in Python, even if your Python code is more efficient. So in Python, if you want fast code, one sort of trick that you use is write as little code as possible. It's very, very stupid. They're actually trying to make Python faster. They had like new initiatives last year, but we'll see how it goes. Yeah, how to make sense of these big nums? Yeah, you can think about it a little bit. Yeah. So ChannyPy, this is something I learned recently too. I found that code that I wrote myself that seems in theory more efficient in that it should take less steps are actually slower than code that I just call the library function. So using default library functions, default data structures is always faster in Python because the core of Python is written in C. Yeah. So Love Markin, damn, I was trying a way to actually create a sense to these big nums. Yeah. Well, you know what, Love Markin? The fact that you got to question 4 means that you beat out a lot of other people in the chat already. So yeah, good for you. You should be proud of yourself for doing that. Yeah. And keep on doing that. I think I've only completed all 4 questions in the contest once or twice, even though I do it every week for months. So, I'm really hoping that, maybe I can do it and maybe one of you guys can complete all 4 questions next week. Okay, so that's it for today's live stream. I hope that everybody got something from it. Thank you so much for coming. Once again, if you enjoy this live stream, make sure you like and subscribe. You can email me for any other thoughts and concerns. And yeah, I'm glad to see the familiar faces, and I'll see all of you guys next time. Bye bye.